Hey everybody, we are happily in chapter 8 and we're looking at linear functions and graphing. So we have a bit of vocabulary that is new and then we're going to have some vocabulary that I hope you remember. So let's get started with that section already. So this is section 8.1 and we're talking about functions. So the vocabulary that we have today, we're going to start off with the word independent variable, and it's considered the variable for which values are chosen, and it's referred to as the input. What does this mean? So if I told you that, I'm going to give you an equation here. If I told you that y is equal to 3x plus 5, and what this equation refers to is I started off with $5, right? This is how much money I had, and then every week my mom would give me $3. This equation would represent that situation. This would be the number of weeks, and this would be the total amount of money that I had. All right, so why am I writing this? I'm letting you know that in this case, when we have an equation like this, we're going to have one variable that's going to be called independent and the other one is dependent. Now, sometimes it's hard to figure out which one is which, but if we were to make a t-table, as we've done thousands of times, we would say put x and y and choose some values for x, meaning come up with some different week values so you can calculate the corresponding financial value, or the amount of money you have. Well, in this case, we would be creating input values for x, get it, independent variable, and we would be getting calculated values for y that depend on x. So, to kind of bring the point home, the independent variable generally refers to the x value, or the value that's in the x position in a way. And the dependent variable is the one that's the y value, and it's the variable that depends on the input variables. Got it? I hope it makes sense. All right, we have a few more vocabulary words. The next word we're going to talk about is the vertical line test, and it is a test to determine if a graphed relation is a function. So here are two words that I'm hoping you guys remember, the word relation and function. And we're going to talk about them in a little bit more detail. But if I have an equation that's graphed, or I have any kind of relation that's graphed, and it could be dots, it could be a curve, it could be anything. So for all intents and purposes, let's make it a bunch of dots. Okay? Really, dots is probably not the best way to say. I should say ordered pairs, right? So the vertical line test tells me if I can draw vertical lines straight through my graph of these points and never hit more than one point, then I've got a function. As you can see, that failed here. This line hit more than 1 point, so my vertical line test tells me I don't have a function here. And we'll definitely do an example to really get a better feel for that word or that phrase, vertical line test. The next definition we have is kind of a quirky thing to write a definition for, but it's called function notation. It's basically a way of writing equations that emphasizes y is dependent on x. Well, really, instead of writing y equals 2x plus 3, we write f of x is equal to 2x plus 3. And what this does is say so by replacing y with f of x, we're saying y is a function of x. Does that kind of make sense? We're saying y depends on x, and you'll see how we'll do problems with this, and I'll explain a little bit more in the example. So that's your official vocabulary, but then we have some vocabulary words that I expect you to know. So what we know, or what we should know. I should expect you to know what a relation is. I expect you to know what a function is. I expect you to know what the word domain is and the word range. If you don't, you definitely want to take some notes and let's chit chat about this. So a relation is any kind of, for our intents and purposes, any kind of pairing of numbers. So I can write a relation as the ordered pairs 1, 2, 4, 7, 6, 3. Any pairing of numbers would be considered a relation. So sometimes we write them as ordered pairs. Sometimes we write them as a mapping. So 1, 4, 6 is being mapped to 2, 7, and 3. And I would write, well, 1 goes to 2, representing this relation here. 4 goes to 7. 6 goes to 3. Sorry about that, Brent. 1 and what did I write 6, 3 twice? What's wrong with me, Dion? 6 goes to 3. We wouldn't have the same thing. Let's change this to like a 4. 4, 3. So 4 goes to 3. That's a little bit better. So what we see here is a relation can be written this way, can be written this way, and you can also graph a relation, right? So a relation can be the grouping of all these ordered pairs. So I have 1, 2. That represents this point. 4, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. You guys get the idea. You remember this. 6, 3 would be about here, and 4, 3 would be about here. So this represents 3 different ways that we show a relation. Now, a function is a specific type of relation. It's a relation where no member of the domain is mapped to more than one member of the range. And so now I've thrown in the 2 vocabulary words that we didn't talk about yet. So when we have a mapping or when we have an ordered pair, when we talk about the x values, remember we called them independent? They're also called, the set of all x values is called the domain. And the set of all y values or resultant values is called the range. So that takes care of these two down at the bottom right here. So what we'll do is we'll come back and we'll define a function. So a function specifically has one member of the domain mapped to exactly one member of the range. And that's really going to be key for us going forward. So in this case, if we look at this relation here, is this relation, can we also put it in the function category? 1 is mapped to 2. 4 is mapped to 7, 6 is mapped to 3, 4 is mapped to 3. 4 is mapped to 2 very separate things. So that is considered not a function because you've got a member of the domain, this group here, being mapped to more than one member of the range. Just for your information, it's totally cool if I had 1 go to 2, 2 go to 2, 3 go to 2, and 4 go to 2. It is okay that the members of the range are being repeated in a way, or at least I have the same member of the range being, or the mapping goes from each domain member to the same range member. That's okay. But the problem would be, so this is a function. This is okay. Woohoo! But it would not be a function if it were the other way around. All right, so we need to keep that in mind. We've talked about domain and range, and now it's off to our first example. Let's see what we have here. So our first example says, determine whether a relation is a function. So it's really good that we had that review. Is this relation a function? So what I look at closely is to make sure that no member of the domain or the first term or the x term is repeated. So I go through and I look carefully. I see 54 is to there, is to 112, 56 is to 130, 55 is to 145, 54 is to 123, 56 is to 1, and I said 56 twice. So here's the problematic piece, because 56, a member of the domain, is being mapped to 2 different members of the range. So this is not a function. And the explanation, I just gave it to you. 56 is being mapped to 2 different things. All right, so let's look. Here's another way of writing a relation, and this relation is written in table form. So x is 4, y is 6, 7 to 10, 6 to 11, 3 to 8, 5 to 4, 2 to 9. Notice that there's no repeating here, right, in terms of the x values. So since the x values are not being mapped to, since one x value is not being mapped to more than one y value, we're good to go. It's a function. It is a function. All right, so now that we have this kind of down, let's go and take a look at a couple of other examples. Look at example 2 here. In example 2, we are going to use a graph to identify a function. So here's where we're going to actually employ the vertical line test. Determine whether the graphs below are functions. Explain your reasoning. So now, instead of having discrete dots, and this was only supposed to be one graph, but I figured we're kind of cool. We can do several graphs. So I'm going to grab a color green here, and I'm going to graph vertical lines straight down. These aren't discrete dots. This is a whole bunch of points that are come together to form this curve called a parabola, and we're going to just draw straight lines through it, vertical lines. And for each of these vertical lines that I'm drawing, notice that there's only one hit for each line in reference to its contact with this graph. When I have that situation, I'm confident that I have a function. I'm going to do the same thing. This is kind of a parabola laying on its side in a sense, or a parabola that with the X and Y interchange. We can talk about that at another time. As soon as I draw vertical lines here, I see that I am hitting twice. Boom, 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 boom. And clearly this is not a function. In a sense, we say that it fails the vertical line test. All right? Here I'm going to draw some vertical lines again. Straight down, straight down. Notice this for -2, it has two different values. When x is -2, we've got two different values. So we can see it is failing. Even though my vertical lines are looking rather wavy today, we can see that indeed this is also not a function. So that's how the vertical line test works. Our next example, let me see if I can find it here. Our next example, example 3, is we're going to use that really cool notation, which is called function notation. So we talked about this a little bit in the beginning with the definitions. Function notation basically replaces y, and it makes us emphasize the fact that y is really depending on x. So f of x is how we read this. F of x is equal to 4x minus 7. F of x is equal to 4x minus 7. So here's how we use that. What is f of 5? Well, what did 5 replace if we look at this this equation here? It replaced the x. So what we're going to do is replace the x also on the other side. And when I do that, I get that 4 times 5 is 20 minus 7. 20 minus 7 is going to give me 13. So f of 5 is equal to 13. So it's just like substituting. In fact, another way of looking at this is saying, what's the value of y when x is 5? But we say f of 5 instead of saying, what's the value of y when x is 5? So here we're going to do the same thing. What's the value of y when x is -6? Or what is f of -6? So I'm going to plug it in just like I did. What is -6 replacing here? It's replacing the x. So I will continue to replace the x on the other side of that equal sign with -6. When I do that, I get 4 times -4 is a -24 minus 7. Well, -24 minus 7 will give us a -31. So my answer is that f of -6 is -31. Not too bad at all. It's really just a bit of substitution, and we're just looking at a new way or new terminology around doing an old thing. Let's go ahead and see what we have for this final example. This final example has two parts. It's example 4. We're going to use function notation on our own. So here we have a boat that travels at a speed of 5.5 miles per hour. First thing we're going to do is to use function notation to write a function that gives the total distance traveled as a function of time in hours. So if I know that this boat travels at 5.5 miles per hour, then the question is, how can I write an equation about that? Well, the function that I'm going to write is that the distance is going to be equal to what? Well, when I think about it, distance is equal to rate times time. We know that. So the distance is depending on the number of hours, right? So the distance dependent on the number of hours is going to be 55 miles, right, times the number of hours. So a more neater way to write this is d of h is equal to 5.5 h, where h refers to the hours, and d, in this case, is going to refer to the distance. So we could also look at using this information that we have, or using this function to answer a question. And here's the question. It says, use the function to find out how long it took to travel 25 miles. Well, since 25 miles is the distance, I'm going to replace d of h by 25. And now I know that d of h is equal to 5.5 times h. So 25 is equal to 5.5 times h. This is what I'm going to have to do. I'm going to have to solve this equation. And I know I'm going to isolate h because I want to figure out the time. I'm going to divide both sides by 5.5. When I do that, the 5.5s cancel out, and I get that the time is approximately, well, 4.54. It kind of repeats like that. And I think an easier way to write it is just to approximate it. It's about 4.5 hours or 4.5 hours. All right? And so that's how we can create a function or write a function in function notation and use that function notation that we've created to actually solve a problem. I hope that this has been helpful. I look forward to seeing you guys very, very soon.